All right, we'll get started in a minute. We'll give people some more time to show up.
这几天就得主要加紧做这个。你那边6690，你那边着急吗？
All right, unless you're talking to me, you want to mute your microphone.
我这东西差不多做完了。我先做 PPT 是吗？对，它那个确实是就是复现是主要的。共享吧。
Unless you're talking to me, mute your microphone.
看你选啥了。对。
Please don't make me mute all of you.
你找的什么？我们刚开始找了一个，后来发现那太难了，做不出来，就是它全是统计的，看不懂。后来选一简单的。
那我们看啥呀？
哦，那就挺好的，对，那就挺好的。我们用的是叫什么 SOM， 跟 SVM 类似。那我们打算就是在用 SVM 和
I'm gonna say this one more time.
主要有些细节比较费时间。
If you're not talking to the me or the meeting, mute your microphone. All right, so I'm going to get started now. I'm going to share my screen. So I'm going to share my screen. You should all see my screen. I'm now going to with a notebook. So the philosophy that I follow is I pick up from where I left off from the previous recitation. I'm just trying to find the right notebook because I've got like 30 versions of this now. All right, so where I left off last time was we had done the inheritance and object modeling in SQL, Neo4j, and also Redis. Now, a couple of questions have come up about Redis. In my sort of solutions that I've walked you through, I've actually, go back in here. Columbia courses, exams. So the question is, no, that's not it. So when I've shown images, for instance, when I showed the Redis image, I showed this screenshot from Redis Commander. You do not need to do a Redis Commander screenshot, so you don't need to install Redis Commander. What's happening in this particular one is the key things that I'm focusing on are, did you apply the pattern for the keys? And so you can see I've got the person prefix, there's a faculty prefix, student prefix, and then there's instances. So I'm just looking to see, and then advises. And then also that you basically store the data as a map. So if you don't want to install Redis Commander, which is obviously fine, this is, I'm logged into the Redis command line console right now. You can just do keys star, and that'll show all the keys. Now, the only ones that I'd be focusing on, as you can see here, that this is basically showing the person student. I've got other ones in there from the previous Redis test, but that shows that you did the key pattern. That also shows that you did the advises. So basically all I'd expect you to do at this point is just you get, and then just pick one of these. Whoops. Should be hget all. And that just basically shows that you did use a hash map. So that's how hgetAll returns. And then basically I would sort of say, I think it's L range of 0, -1, and it's probably advises FEDO1. I think that's the syntax. So I'd have to go back and look what it is, but basically, just that you would actually have to remember what it is now. Anyway, you can look it up, but basically just that's a list, and I'm not even going to check that, but mostly that you have the key pattern, and that also you'd store things as the map. So you don't need to store Redis Commander. Just using the command line and doing what I did would be fine. Then you can just take a screenshot of that and submit it as your image. I can hear this. Well, obviously I'm talking, and apparently other people can hear it. So I'm not quite sure what to do. The sound is coming out from my end, so this must be a configuration error on the recipient's end. So you can try and fix it, but I'm not quite sure what it is. But the net of it is, at this point, all you need to do is a screenshot like this would be fine. And I will look up, you can just look up what the key is. Well, actually, let's just do it now and get it over with. Get list Redis. Oh, that's what it says it is. Oh, because it doesn't like the parentheses, sorry. That's what you do when you're in a program. So if this were in Python, that would be the Python call. This is really getting annoying. All right, let's go see what else is going on here. Oh, I probably have it in the wrong place. Yeah, so this has got to get moved. All right, so that basically, I think if you do like 0, -1, it gives you all of them. Yeah, so it's going to give you all of them if you do 0, -1. So just, that's the command, is L range, and then just the advisors relationship. If you do 0, -1, it'll show all of the advisors. So you do not need to do Redis Commander. This screenshot would be fine. So that's all you need to do. All right, so now we're going to move on to the next part of the final. All right, transactions. You should create this table in W411 final. So in that schema, if you go look, I just have a few accounts in there. So if you go and take a look at the definition of this thing, that's the create statement for it, which is ID's an int, it's not null, and it's auto increment. You typically would not do auto increment for an account ID. There'd typically be some pattern in it, but for the purposes of the final, it's fine. Balance is the amount that's in the account. And version, we'll talk about it in a minute, and then the primary key is ID. So that's the schema for the banking account. You can see it's basically the same thing here. So the fields have the following meaning. ID is the account ID, balance is the amount. Version is a UUID in string format. Any program, any transaction program that creates a banking record or changes one basically generates new UUID and updates it. So you have two programs, transfer pessimistic and transfer optimistic. Now somebody asked the question, how does the data get in there? And I'm gonna go see whether I can find it. So let's see whether I wrote the code in here. No, it's not in this notebook. So let's go open another one. I delete the code. I've gone through these recitations, so my notebooks are all a mess. It looks like it has answers in it. Yeah, this one looks like it has the answers in it. All right, so go down here. We're finally back at the transaction one. All right, so this is what creates an account. So I'll copy this over to the notebook that we're currently working on. So I wrote this function first, create account. It just takes a balance. It can't take an account ID because the account ID is going to be generated. It does the following things. I get a new connection. If you go back to the beginning of the notebook, up to the very beginning of the notebook, you'll see that, in fact, I gave you some helper code, and this function just gets a new connection. In a real system, you would have this thing called connection pools that get reused, but don't worry about that. Just creating a connection per transaction is not a good practice because creating connections is expensive. And there's a concept of a connection pool. I mentioned it in class, but don't worry about it for the purposes of this. This just gets a new connection and that'll run a query. So now I'm going to go back down to where we were before. All right, so where am I now? All right, so this is going to create a connections account. So I'm going to go get a new connection. I'm going to create a cursor. This statement sets the isolation level to serializable. If you remember from the lectures, there's a bunch of isolation levels for transactions in a relational database. Serializable is the strongest one. And I just set that one. Probably we could have had something that was slightly less stringent, but this is fine. And so now I've got a transaction that's been started and the isolation level is serializable. I generate a UUID, a version ID, and then I insert into banking, and I just basically give it the initial balance and the version ID. And then these are just the slots that it's going to go for templates. So I run the query. The two parameters are balance and version ID. And then actually, this is probably a mistake. I've been playing with this. So I would actually pass the cursor in under both of these things. So fetch is equal to true, cursor is equal to cursor. Because what's happening is the way the database engine figures out what a transaction is touched is based on a cursor. What is the cursor touched? And so by creating a cursor and then passing it in, right, I'm just basically saying when you're in run queue, use the parent cursor so that the database kind of gets it. So that's going to go create it. Now, if you think about this one, what this does is it says, select the maximum ID as the new ID from that table. Well, since I did a transactional insert, right, anybody else's insert is not going to conflict with mine. So the max ID is going to be the one I just inserted because it's auto increment. And so that'll give me the maximum ID. The only person that can see that is me. And then I will go run the query, and that's how I know what the account number is. So again, if you're not actively talking to me or the meeting, please go on mute. I don't want to mute everybody. All right, so now basically just going to go and create an account. I will just give it a balance of, and hopefully if the environment's set up properly, it'll work. All right, I have to go back and import UUID. We'll go run this again. Okay, listen, I'm going to say it one more time, and then I'm going to mute everybody. This isn't rocket science. If you're not talking, go mute your microphone. All right, so. All right, we'll do it my way. All right, so basically I just had the name wrong here, so I'm just going to call this cursor. I'm going to run it again. Now cur is not defined, so this is what happens. So it's going to be cursor. I'll go try this one more time. Super good feeling about it this time. All right, so you can see that it returned 8. If you go back into the database, not surprisingly, you can see that that was the account that was created, and it generated a UUID. So the next thing I did is I wrote a simple function that will get the balance. So I'm just going to get the balance of an account. So actually, anyway, before I move on, when I do this in a room, this is family photo time. So if you want to take a screen capture or something, I'll just give you a minute to do it, and then I'll move on. All right, so I'm going to move on. This is going to be get balance. So I'll go back into the other notebook. And this is just going to be the get balance code. So if this receives a cursor, so the calling function started a transaction and wants this call to be part of that transaction, it'll pass the cursor in. If there is no cursor, then what's going to happen is I'm going to make a connection, create a cursor, and note that I created the cursor. Otherwise, I'm going to remember that I didn't create it. And then I just run saying select star. And then if I created the cursor, I'm going to get rid of commit the transaction, get rid of the connection. I repeat this code over and over again, this code segment and this code segment over and over again in these functions. I did that for clarity This is a bad programming practice. You never have the same snippet of code used over and over again. If that's what's happening, that's a different function that we should call. But if I call the function here, you then have to go look into that function to figure out what's going on. So for the purposes of this, it's a little bit clearer or more clear, but that's not a good programming practice. And so I'm just going to run that. And then I'm going to do get balance. And I'll give it a count 8 and run that. And you can see that it gives you a balance for that account. Now, since I didn't pass a cursor in, it basically made one and then committed. So you can take a shot of that. So that's just get balance. And so that's a function that will start a transaction and get the balance, or if it's being called by a transaction that passes a cursor, it'll do it in the context of that cursor. The next one is basically the same. Is instead of getting the balance, I get the entire account. And so you'll see why in a second. But that one will get the entire account. And then if I just call get account, and I give it 8, it gives me the entire account. So the balance, the account number, and the version ID. And we'll see how I use that in a second. So then I'm going to start adding some other functions. So basically, I'm going to start adding them here. So we'll go back over. This updates a balance. And so this function will just update a balance. It's taken an ID and the new value for the account balance. And then again, it may or may not get a cursor. I played the same game at the beginning and the end with starting a cursor if I need one. But you can see that this one will then generate a new UUID because I'm changing the balance. I'm changing the account. And when I run the update, I give it the new balance and the new version. And so this one here, if I basically do update balance, I'm just basically going to do it. Print get balance of account 8, update balance, and it's going to be 8, and I'm going to make it 1002, and then I'll run that. All right, and then I'll do get balance. Eight, and run it again. And you can see it gives me the new balance. And so I've changed it. Now if I go and do get account, and I give it 8. Actually, let's just do this in another cell. So I'm going to do get account of 8. All right, so the next cell I'm going to do is update balance. And it's going to be account 8, and the new balance is some other value. I run that. And then if I go run this again, you'll notice it has the new account balance, but it's also got a different version ID because the account's changed versions. It's been modified. And so that's update balance. And you can just take a look at that and capture it if you want. Now, this one does the same thing, but it sort of does it optimistically. And you'll see what that means in a second. All right, so I'm going to copy this one. Going to add a cell. All right. Going to run that cell. And so the first thing I'm going to do is I'm just going to basically display the balance. So I'll run that cell. So it's 3001. Right. I'll update the balance. Now you can see in this one, it takes the full account and the amount, not just the account ID. So I'm going to go here and basically say X is equal to get account of 8. And I'm going to display X. So I get the account with the version number. Now I'm just going to go update the balance and run it. So this simulates potentially another transaction updating the balance. And so then what I'll do here is I'll basically do update balance optimistic. And I'll give it X, which was the account. And I'll give it another balance and run it. And it says something. So what did I do? Oh, X is update balance. X should have been get account because I'm an idiot. So we'll try this one again. X is going to get the account. I'm going to update the balance. Underneath it. And then I'm going to go try run that. And it's going to say optimistic transaction failed because the version number changed underneath it. And so I did not lock it or assume it was locked. And so I just say I'm only going to write it if it hasn't changed since I read it last. And so that's update balance optimistic. And then the final thing is we put the pieces together. So this will do a transfer as a pessimistic transaction. And so what I'm going to do is I'm going to say transfer pessimistic. I get a connection, I get a cursor, I set the isolation level to serializable. And the reason for that is I'm going to read 2 accounts and I'm going to update 2 accounts because I'm making a transfer. So I need to manipulate both of them. The isolation is necessary to make sure that I don't overwrite balances, that somebody else doesn't update the balances and then I overwrite them. And the transactions is I need for atomicity to make sure both updates happen or neither. So I ask for the source account and I get the balance. I prompt and say, this is the balance, do you want to continue? If they specify yes, I ask for the target account, get the balance, ask if they want to continue. If they do, I ask for the amount, and then I perform the transfer. So I compute the new balances, and I do the update, and then I commit. So this logic is pretty straightforward. All right, so now what I want to basically do is transfer pessimistic. All right, what's the source account? It's 3. The balance is 200. Do I want to continue? The target account is 2. The balance is 300. Do I want to continue? The amount is, I'm going to transfer is 50. And then if I basically do get balance, and I give it account 3, you can see that it did the transfer. So the balance is 150. And so that basically does a transfer pessimistically. And so the way it does it again is it needs 2 capabilities. Capability number 1 is isolation, because it's reading values and then writing updates back. If it didn't do that isolation, somebody else could change the data and then it would be overwritten by this transaction. So you would have a read-write conflict. You'd actually have what's called a missing update. So I have a transaction isolation level to prevent an overwrite, and then I need the transaction for atomicity to make sure that both updates happen or neither do. The logic for transfer optimistic is extremely similar. So we'll just put that here. So transfer optimistic. And again, I'm going to go through the prompting. But you can see the first difference is I get the account, not just the balance. And also, I don't pass a cursor in. So this step is an independent transaction. It gets the balance and commits. I'm not read locking the record. Same thing here. I'm getting the target account, but since I don't pass a cursor, it's not going to read lock it. And so now it's going to get the target balance. I'm going to ask for the amount. So now I know everything I need to do. This is when I start a transaction and I update the accounts. If the versions have not changed, the updates will work. If one of them is changed, it will fail. And so the only part of this thing that's actually transactional is that part where I'm reading the accounts, determining whether or not the balance has changed, the version has changed. And if it has, I abort, otherwise I commit. So I'm going to go run this. And I'm just going to basically copy this. So we're basically just going to go and say transfer optimistic. And again, it's going to be no parameters. So I'm going to run it. So transferring optimistically, the source is 3. I want to continue. The target is 2. I want to continue. The amount's 100. And so if I do get balance, I'll pick 3 and run that. It's 50 because you can see I moved $100. So externally it looks the same. You can't really tell any difference. The place you can see it is when you try and run them at the same time. So basically I'm just going to get some new windows. Yeah, I could terminate that. So I'm going to go shell, new window, grass is nice, and shell, new window. Silver aerogel is kind of freaky, but what the heck. All right, so I'm basically just going to go to the directories where I have these things. So CD, Twiddle, Dropbox, Columbia courses, fall 2018, CDW4 exam LS. So I'm just trying to remember, is it, I guess it's test transactions, so I'll give that a try. All right, so I'm going to ask, do you want to do it optimistically or pessimistically? So I'm going to do the same thing down here. I'm just going to make this a little bigger. Go to that directory. All right, and I will do test transactions again. All right. Same thing. Do I want to do it optimistically or pessimistically? So I'm going to do both of them pessimistically to start. So I want that to be bigger. That'll make that one bigger. And that'll make that one big. So I'm going to say do this one pessimistically. And then I'm going to do this one pessimistically. So transfer pessimistically, transfer pessimistically. I'm going to do 3. Yes, I want to continue. I'm going to do 2. Yes, I want to continue. Right, I'm not going to enter the amount. Then I'm going to go down here and I'm going to go 3. Now you can see the balance is 50 because you can read, because this transaction's not tried to update, so it's only got a read lock. So this second transaction can read the value because read locks don't conflict. I want to continue. Target ID is 2. I want to continue. And then you'll notice that if I hit the amount here, right, and try to transfer an amount, that blocks because it's now trying to write the accounts that this one has read locked. And so it can't do that. So it's going to block. So it's now, this transaction is now waiting for that one. If I go back in here and type 50, you can see that transaction failed because it started to wait on this one. And that created a deadlock. And so this transaction aborted because it detected a deadlock, which means that one ran. And so we had a deadlock, 2 transactions were waiting on each other, it detected that with the wait for graph. It aborted one of them. And it allowed, when that one aborted, it broke the deadlock, which means the second one could complete. So that's an example of 2 pessimistic transactions conflicting. So now we'll go do this again. Right. This one is going to be, we're going to do it optimistically this time. And so we're going to transfer, this time we're going to go the other way because I'm running out of money. Source account 2. Balance, yeah, I want to continue. Target account 3. There's nothing in there. So I want to continue. All right, so I'm transferring optimistically. Over here, I'm going to transfer pessimistically. So what's the account? It's 2. The balance is 500. So I want to continue. Account 3. Balance is 0. I want to continue. Now you remember when I got the 2 pessimistic transactions in this state, this is where the deadlock happened. But you'll notice now if I do this, that one runs fine. Because this one's optimistic. It read the values, but didn't lock them. It's going to check for a conflict. And so when I try and do this, you're going to say, got an exception, optimistic transaction failed. And so this one began a transaction, but detected under the covers on the right that the values changed. And so that kind of highlights the difference between pessimistic and optimistic transactions. In a real transaction manager, they almost never use optimistic transactions, and they're very rare. And moreover, this particular behavior here, I'm doing it explicitly. So I'm checking explicitly whether or not the balance has changed. So I'm basically reading it and saying, is it different? A real optimistic transaction manager does this under the covers, so you don't need to explicitly version the tuples. But to make it explicit, and because most transaction managers don't support optimistic, I just did it explicitly here. And so that kind of highlights the differences between pessimistic transactions and optimistic transactions. And I'll kind of go, this is just transfer pessimistic. So that's basically the logic. I'll make it a little bit smaller. So that's transfer pessimistic. Get a cursor connection and a cursor, set the isolation level, go through the prompting. But the reads that are happening here happen under this transaction getting read locks. When I try and do this, I have to get an exclusive lock on both accounts. If I can do that, then I can update it. If I can't get the locks, I'll wait until I can, or I'm aborted. And then I'll do a commit and close. And this is optimistic, which is basically the same logic, but I don't lock the records in the parent, this transaction. So these things are not locked when I get to here. So I read them, but they weren't the locks, they're not locked. And then I basically go and say, if they haven't changed, update them. And then that is how optimistic and pessimistic transactions work. And so I'm assuming everybody was capable of taking family photographs when I did this. You can send a chat message if you couldn't take a family photograph. All right, so we'll move on. Star schema. I'm not going to read the funny part of this, but basically, you're supposed to install the Sequila sample database. You can get this. This is the canonical example, and it's like the default sample database for MySQL. If you want to see what it looks like, you can just go and look at the Sequila DB schema. There's a bunch of images of it out there. This one's kind of helpful. I'll make it bigger. It's broken into kind of 4 areas. Right. This area is information about customers. So this is a customer, customers have an ID, blah, 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 blah. And then they have an address. And the address has factored out city and country. This section is information about stores. So there's a store may have a rental event. Somebody rented something at the store. And somebody may later pay for that. And a store has a staff. And then stores have a location. So the store also has an address. And then if you look over here, this is information about the movies that the store has. Now this is kind of very highly factored. This is similar to what's in the Neo4j database. We're not really going to pay very much attention to this. And then the final one is that there's a bunch of views. And there's a couple of stored procedures. But again, we're not going to worry about those. It's basically going to be these two parts of the schema that we're going to worry about. So we'll go back over here into the star schema one. So remember, in a star schema, there are fact tables and dimensions may have hierarchies. So I tell you what the two most important facts are. It is rental, so something was rented, and payment, they paid for the rental. So you're going to build a star schema with that fact table and some dimensions and hierarchies. So what you're supposed to do is define the DDL statements that create the fact table and the dimension table, write the SQL to basically load any of the tables that you do, and then write 3 queries: a roll-up operation, a slice operation, and a dice operation. We went through this in the last lecture of class. So, all right, so go back now on Word Final. All right, so that's that one, it's not this one. All right, so basically, we'll go back over here. If this is my Sequila schema, and where I put it again, right here. So I'm going to set that as the default. I'm going to close the other tabs. And if you look at the tables, there's a bunch of tables that come with Sequila, but you'll notice there's some things that I've called dimensions, and there's a date table. And so you can see I've added these tables. So this is the nucleus. It's the rental payment facts. When I select that, this is the fact table. This is just what is the ID of the rental? So what is the ID of that transaction? If you go back in and take a look at rental, you can see that it has a unique ID. This is the rental date. This is the thing that was rented. This is the customer that rented it. Return date, which staff member handled the checkout, and when was this record, this tuple, last updated. And then if you go look at payments, it's got a similar structure. The payment ID, the customer, the staff, which rental transaction is this the payment for, how much was paid, and when did it happen. So the rental fact table is clearly a join and a project. And basically, the statement for that is basically, start with select star from rentals, join payments. Sorry, it's payment, not payment, rentals. And it's just rental on rental.rental ID is equal to payment.rental ID. So I'm just going to join those two tables. And so that has pulled together. So it's got the rental ID, the rental date, the inventory, the customer, when it was returned, who the staff was, the payment ID, the staff ID, the amount, etc. So all you really need to do to create the fact table is to just select a subset of this. So I'm going to select rental.rental ID, rental date, I don't need to alias that. inventory ID. Inventory ID. I'm going to get the customer ID from rental. So I'm going to get this customer ID. I don't need the return date. I'm going to get rental.staff ID. It's going to be payment.payment ID. I don't need the customer ID or the staff ID because they're going to be the same, or the rental ID. I'm going to do payment.amount. And then I will get rental.rental date. And if I want, I could get payment.payment date. From that join, unknown column rental data, rental.rental date. All right, so that's the basic shape of the fact table. Rental. When did this rental event happen? What was rented? Who rented it? Who checked the person out? How much did they pay? And I clearly have rental date twice, so I don't need that. But that's basically how you make the fact. And so to make the fact table, you would just to create new fact table and call it whatever you want. Create table, new fact table. Let's call it recitation fact table. If I can spell recitation. Create table, recitation fact table. Recitation fact table as that statement. So I'll go run it. It made them. And so now if I just go down here and do select, well, I'll go back into the notebook and do it. So I'm just basically going to go and put a cell here. And it's going to be percent SQL, select star from recitation. Make this bigger. Recitation fact table, limit 10. We'll just go run that. Of course it has. So now we're going to go reconnect up here. Let's go up here. Run. Then we'll go back down here. Try running it. Yeah, so now I've just got to change schema. So it's just going to be W4. If you ever want to change schema and not put it in the statements, you can always just do this. Oh, it's going to be Sequila. So I'm basically saying this is the equivalent of changing the default schema in MySQL. So I just run that, and you can see rental ID, the rental date, what was rented, who rented it, who would check them out, how much did they pay. So what was the payment ID? So what was the ID of the payment record? How much did they pay and when did they pay? So that's basically built the facts. So now I need dimensions. If you go back and you take a look at the Sequila schema, right? In the past, when I've had students think about this, they've tried to build a schema here, a dimension here, but it gets kind of wonky because there's categories and then film categories. So this is an associative entity. And you can wind up like, what does this mean? They can be in lots of categories. It's not really hierarchical. So genre is not inside of, the genre comedy is not inside another genre, so it's not hierarchical. So if you did one in here, I wouldn't mark it wrong, but this is not a good place to do dimensions. The obvious dimensions over here are around time. When did this happen? And where did it happen? So when you think about fact tables, like, you're probably not old enough, but like when you take English classes, when you're junior high school or senior high school, like I did, and then they sort of teach you how to write a news story. It's who, what, when, where, why. What are the facts? So those you can think about as the dimensions in this case. And so who makes sense, when makes sense, and where makes sense in this case. And so there are dimensions, and then there are hierarchies. Don't worry about this ending. This is a UML ending. It means contains. I just put it in there so you sort of see some differences between UML and ER. But this is clearly a dimension for time. Year, quarter, month, and day of month. So that's a perfectly good time dimension. And then there is a where dimension. And what I did is, there's really two dimensions. Where does the person live? And where's the store? In general, they're the same place, but they don't have to be. So I could ask the question, like, please tell me how often customers rent a video from a store in a different town from where they live. So the hierarchy is country, district. District is a generalization of state, city. And then the customer address dimension and the store. Where's the store and who was the staff? So I have three dimensions here. Staff address dimension, customer address dimension, and day of month dimension. And the customer and staff dimension share a hierarchy, which is country, district, city. So if you go take a look at my star schema, it's not a particularly good star schema, because this is not a particularly complicated business problem. But here's the fact. What's the staff store dimension? What's the customer address dimension? And what's the date dimension? So that's my star schema. And this is how I computed the hierarchies for that star schema. So if you go back into my database, and we get rid of this, and we just basically say, sample the date dimension. And so you can see, you need a key, a foreign key relationship. So there's a foreign key relationship. If I have a fact, a foreign key relationship to go find the date. So for a specific date, nothing may have happened, or many things may have happened. So that's why this is 0 or more. If I have a fact, it always has a date. So that means there's a foreign key relationship. I can just use the quote date, or the timestamp in the fact to find it. So what I did is, probably should have taken the times out of this, but I kept the time in there anyway, despite the fact that I don't use it. But in this table, this is basically just the key. So how did I make this? Well, the way you make something like this is, obviously, I will go back and say select rental state from rental. So rental date from rental. Those are all the rental dates. So those are all the moments in time when a rental happened. Okay, well, it's not exactly what I want. So what I want to do is I'm going to do select rental date. Year of rental date. Month of rental date. Day of month. These are all built-in functions in MySQL of rental date. I'm probably got to put commas here. So that'll do it. And so when I do this, that is the ID for the date. What was the year? What was the month? What was the day of the month? So these are kind of awkward names. So I'm just going to go as year, as month, as day of month, just so that they're a little bit more clear. So the column names are not so wonky. But there's also payments. And so I have to do a similar thing here, which is select payment date, payment year, month, from payment, and I'll go run this one. So I basically did the same thing on that table. Now there's just one other thing I need to do, which is we wanted the quarter. And so the quarter is the ceiling of the month of the rental date divided by 4 as quarter. So divide the month by 4 and then take the ceiling. You do the same thing here, only for the payment date. So we'll just go run this one. And so you can see it gives the quarters. First quarter, second quarter. Not a lot, it's probably just doing limiting, but you can see May is in the second quarter. And then so all you would need to do to get the date dimension is basically run that. So that's going to give you all of them. And since it's a union, it's going to eliminate any duplicates. And then you would just do create table, date dimension, recitation, date dimension as that. And so invalid default value for rental date. No idea what that means. Rental date. Okay, not quite sure what that's about. Default value for rental date. Select rental date, rental date, rental. Oh, The problem here is the column names. So you would have to do this. Fact date. Fact year. Probably should not call it fact. Sort of like dim date. Dim year. Dim quarter. Dim month. Dim day of month. And that's going to be dim year. That's going to be dim date. Dim quarter. And so this way, the column names are the same. So we'll just test that. So now the union should work. Involve dim date. So what is going on here? In doubt. I don't know what's going on here. That should work. And select rental as dim date. Yeah, I'm not quite sure what's going on here. This should work. Invalid default value. So maybe it's payments. Let's go and try run this one. Right, there's another way to do this. So basically, we can just go and set debt recitation, date dimension as. We'll see whether we can make it from this one. All right, so it did it there. So there's clearly something down here that I messed up. So what I can do is insert into recitation, date, dimension, select payment date. Insert into recitation date. That was the problem. Maybe. Date dimension doesn't exist. Recitation date dimension. Let's go refresh all. Recitation date dimension. Insert into recitation date dimension. All right, so that did the insert. I don't know why the union didn't work.
Yeah, perhaps column names should be different.
No, the column names should all be the same. I must have made some typos somewhere. I just didn't, I can't figure it out at this point. This is what I do all the time in between lectures. So I'd have to go back and take a look at it, but that way also works, is to just insert it. And so if I go back in here, I'm going to add a cell. And so that built recitation date dimension. Oh. And so those are the date dimensions. If I wanted to find out when facts occurred, Recitation date dimension. Dot rental date equal to, and then this one down here is dim date. So that's going to be dim date equal to Sequila dot recitation fact table dot rental date. We'll go try, probably put that one in a different cell. Select star from Sequila recitation date dimension. Join, don't need the limit there. Limit 10.
Space before limit.
Yeah, that would help. You also understand that every time you do that, it sounds like God is talking to me. But okay. God gets things right, apparently. So anyway, it joins it. I probably would actually do it the other way around. Because it looks, I don't know. Let's Sequila join that, so we'll try that one. From Sequila recitation fact table, join Sequila recitation date dimension on. All right, so I've got the fact and the date. You play the same game with year, with the address. So the first thing you just basically do is select star from address, right? So this isn't quite right. So what I basically want here is address ID. I don't care about the street, right? I don't care about address 2. I want the city ID, but I also want select. We'll go see what it is in city. So it's just called city, select city from city where city dot city ID is equal to address dot city ID as city. We'll give that a try. All right, so now you can see I have the address, the city ID, the city. I want to do the same thing here. I want the district, and then I want to do the same thing with the country. Right. Unknown column country ID. All right, so what is it called in country? Country ID, what is it called in address? Oh, yeah, it's a little more complicated than that. It's We're gonna go back here and try it slightly differently. We will say, we will go and say select country ID from city where city dot city ID. I'll actually just copy this one. Select country ID from city where city dot city ID is equal to address ID as country ID. All right. And then let's try this. Don't need that extra as. All right, so now I got the country ID. And then I now need to go and get the country, I guess it's called, from country, where country dot country ID. Yeah, no, so now I'm gonna be going through, but the address has got the anywhere. So I've got, may not be able to, so from the address I can get the city. All right, so I'm gonna have to do a join here. So anyway, so that gives me part of it. All right, so I'm gonna go city ID as city, district as country ID, from address. So I'm just gonna go do a join. As a join, select country ID. No, that's not gonna work either. So I have to do this as a two-step process. So step one is going to be create temporary table, TMP1 as that, right? So I'll go create that. So now I'll go select star from temp1. Gave me what I needed. So now I'm going to do select temp1 dot star, comma, and I've got, so I've got the city ID. Oh, I've got the country ID. So now I'm going to do select country from country where country dot country ID is equal to temp1 dot country ID, right? From, you know, from temp1. So that should work. Unknown column country dot country ID would help if I could spell. All right, so that's kind of a crappy name, so we just go country. Try it again. Address ID, city ID, city, district, country ID, country. Okay, so that's going to be the basic dimension. So we'll do create table recitation address hierarchy has that. All right, so I created it. So it ran all these queries. So let's just now go run this one. And so that's the shared hierarchy. So now if I want a customer dimension, you can see that it's got an address ID. So to get the customer dimension, it's just basically going to be select star from Sequila customer, join recitation date dimension on recitation date dimension dot address ID is equal to customer dot address ID, right? Unknown column recitation dot recitation date dimension. So what did I do here? Oh, it's not the date, it's the address. That was clever. It's going to be not recitation date dimension, it's going to be recitation address hierarchy. All right, so customer ID, store ID, first name, last name, email, address ID, blah, 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 blah. Lots of stuff here. But I don't really need all of that. So I'm going to basically do, let's set this, I'm basically just going to go customer dot customer ID, customer dot first name, customer dot last name. Probably don't need the email, I can always add it later. Customer dot address ID, address, no, it's going to be address hierarchy, what do they call it? No, recitation. We call this same thing. Refresh all. It's recitation address, hierarchy dot city ID. City district. This down some. It's going to be country ID and then country. Right. Down to try. All right, so customer ID, first name, last name, address ID, city ID, city, district. This, I can use the customer ID as the unique ID because that's the bottom part. If you go back and take a look, that's where it is. And then you can just basically do the same thing for store and staff. So in essence, if you basically go to a staff, now the thing that's remarkable about this video company is that this video company has 2 employees and 2 stores, but it seems to have customers all over the world. So super excited about understanding how somebody from Kabul, Afghanistan rents something, you know, from these stores. So I pre-built the staff store address dimension. And so you can see basically it's the staff ID, the store, and then where it is. So I'm not quite sure how somebody in Kabul rents something from somebody in Canada, but we'll worry about that later. And so if I go back over wherever this one is, I'm just going to close all the other tabs. So if we go back in here and take a look, right, that's the recitation fact table joined with the date dimension. So I'm just going to copy this back over. And so what I'm going to do here, and I've shown some of you this trick. Cancel. I've shown some of you this trick, but I'm basically going to do select right. So that is kind of the first join. So that pulls part of them together. So we'll just go run that here. All right, so I don't need limit 10 at this point. Limit 10, so I don't need limit at all. And it's going to fetch for a while. Now this is one of the things that it's slow here, but one of the things about copy tables is that you can actually put additional indexes on them because they're first class tables. And those indexes don't necessarily have to be the same one as the base table. And so you can see that I'm actually doing this join here. So to speed this up, I should actually do the index on that. That's going to take a while, but there it is. All right, so what I'm going to do at this point is I'm going to do create temporary table, TMP, sorry, it's going to be in this case, fact date as that. So we'll just do this one. So that's going to run for a minute. And so could I go over how I did the fact table one more time? And then the recitation date dimension. So I will go back to those in a second. Let's just let this one run. And so that's going to pull together facts and the dates. All right, so let's go through this. This is exciting. All right, so while this is happening, fact table one more time. So how did I create the fact table? So we'll go through that one more time. All right, so that one's done. So we'll just hold that thought. We're going to go and do the fact table again. So the fact table is basically a join. So there are two facts here are in rental. You don't need to do fully qualify these things. Okay. Rental.rental ID is equal to payment.rental ID. So that's going to go and create right. And so those are the sort of all the facts, but I don't really need all of this. So I'm just going to do rental. I need the rental ID, the rental date. Inventory ID is probably not the end of the world. Need the rental.customer ID. Rental.staff ID. Payment ID. Amount. I think that's it. Rental ID is, that's going to be rental.rental ID. Rental. Can't have spell inventory. Rental.customer ID. All right, so that's basically it. I may have forgotten a column or two, but that's how you do the fact dimension. So you can see it's got the rental, what was rented, who rented it, when it happened, how much they paid, who rented it. And so that's basically some kind of query like that. I can't remember exactly which fields I picked, but it's I probably put the payment date in there, but that's the basic query for how to create the fact. Go back to the date dimension is, just go and copy this for now. So I just actually put it in here. If I do select rental date from rental, that's going to show me when all the rentals happened. That's going to show me when all of the events happened. So these are all the points in time something happened. So that gives me all the dates. So then if I want to screw around with this, I can basically say, now I'm going to have to go start again with that aliasing. So it's just basically going to be rental date as dim date. From rental, sorry, dim date. Year of rental date as dim year. Month of rental date as dim month. Day of month, is it day of month of rental date as dim day of month. From rental union, and it's just basically going to be the same thing, but I'm going to replace rental with payment. Didn't want to do that. I hate computers. So rental. All right, so we're going to close that. All right, so if you basically go and look, this is the ID of when it happened. So I'm going to use that as the unique ID, the year, the month, the day of the month. And then I'm just going to do one more thing. I'm basically going to go in here and do ceiling of rent of month of rental date divided by 4 as quarter. And then I'll do the same thing down here, but for the payment date. As quarter, run that. And then you can see that year, quarter, month, day of month, and then something that uniquely identifies it. So I'll just basically go back here, make this a little bit smaller. Whoops. But you can just take a screen capture of that. So all you really need to do is to just create a table of that. No, I know what the friggin' problem was. Right. Put error in your SQL. Table food, let's select star from. Something like that. Of course, every derived table must have its own alias. Right. Yeah, I have no idea what's going on here, why it doesn't think there's a default, but basically that, if you want instead, you can do what I did previously, is the first one is to just create. So I'm just going to basically go and get rid of this nonsense. Let's start from rental. Right, so what is not like here? Select star from rental. As Right, so that's going to create the table foo. So you can see it created it. And then the next one is just basically insert into foo, select. And then that's just going to go add them. And so that'll add them into the table. So since I can't seem to get the union to work, that will create it. And then I can just add them in over. So anyway, I did the fact table and the date dimension. All right, so we're good on that. So let's go back. That's recitation fact table. I went and I made that. So we're just going to go select star from date. I'm going to put a semicolon there. And so that is the facts and the date. And then I can play the same game here, which is I'm going to say select star from fact date. Fact date. Join customer address. I call the recitation. Well, I actually already did this one. Customer address dimension on. Let's see what this one is. Customer ID. On fact date dot customer ID is equal to customer address. And is it Dominion? I spelled this one. Dominion. Customer ID. Right. This one will take a while. So you can see it's fetching. So that's going to pull the facts. This is the fact, the date, and then the customer. And if I wanted to, I could just create, I don't know what it is now, temp 4 as, create table temp 4 as. So we'll go run this one. Yeah, and this is the one that starts getting freaky. So we'll just take this aside for a second. So we'll go to this one. Okay, so there's that one. So now we just have to go and make the columns unique. So it's going to be rental ID, rental date, inventory ID, so now that one can just, so that one can just be fact date dot star. Do I have the customer ID twice? Fact date dot star. Join fact date dot star, comma. Customer ID is going to be there. First name, last name, address ID, city ID, district, city, country ID, country, from fact date join, what is it, customer address dimension on fact date dot customer ID equal to this. Right. So go give that a try. Because it's, all right, so let's just make sure we don't have any duplicate columns here. It should be okay. So now I'll go try to creating the temporary table. Go try that. And so now when I get here, it's going to be fact, date, and then the customer dimension. Adding in the staff store is pretty much the same thing. I'm not going to actually do that because it's just pretty much just joining that. So you see how I'm building this thing up. So I just go around that. And this is actually, if you think about it, the pivot table. So all a pivot table is basically a flattened star schema. So I'm not going to worry about the store right now. If you don't want to do the staff store, that's fine. Because we've got 2 dimensions here, it's good enough. You can see that it's a lot of little tedious SQL stuff. So I'm just going to basically do create recitation fact dim as, right, create table. We'll just do that. And so we now have fact dim, so we're going to go refresh this all. And we're going to have fact dimension. All right, no, that's not it. Fact date. Refresh all. Recitation. What do I call it? Recitation fact dim. All right, so I'm not going to worry about adding in the store dimension because I do want to get to the next question. But you can see rental, when it happened, inventory, customer, staff, payment, amount, payment. These columns are the facts. Now this is that joined with the date dimension. And then this starts to bring in the customer address dimension. And then we would just keep going in here and we would just go and add the staff. And we could do that by joining on the staff ID. And so if you did that and you had this big wide flat table, that's basically the pivot table. And then I asked you to do the following. So I asked you to do a roll-up operation. So the easiest roll-up operation, if you remember, go back in here, roll up. It just basically takes a bunch of stuff and kind of merges it. So I'm going to go take things and compress them. So I'm just going to go kind of make a smaller one. So the easiest roll up to do is just sum of sorry, count of star as rentals, sum of payments as revenue. That should just do it. All right, so what is it now called? It's called amount. And so that's the easiest roll up, which is there were almost 100,000 rentals and this was my revenue. So that's the easiest roll up. A slice is just basically this. I'm basically just going to go select star from recitation fact dim where dim year is equal to, I don't know, 2004. All right, so what are my years? Oh, it's dim year because I'm a dim guy. No, it's dim year. Dim year is 2005. All right, so that's just basically a slice. Should only pull the fact stuff in. So it would just basically be select rental ID, rental date, inventory ID, customer ID, staff ID, payments ID, amount. So this would be an example of a slice. If you could spell, it would be inventory. So we're not going to worry about that one. All right, so basically that would be, it's inventory ID. That would be a slice because I basically cut on one dimension and one value. If you wanted to do a dice, nope. That's a dice because I cut kind of in two dimensions. And then I could also roll this up if I wanted to. So a roll up here would be count of star, sum of amount from, I'm just going to comment this out. Right, doesn't like that. What does it not like here? Don't need the from twice. And so those are how many rentals and how much revenue did I make in 2005 in Canada. And so that's kind of a classic OLAP query. I basically went and picked a year, and then I picked a place, and then I aggregated. So that's an example of a slice. Putting two of them together is a dice and then a roll up. And if I wanted to do, go back in here, 2006. So I only have information from 2006. So dim year equal 2005. Right. But basically that's slicing, dicing, and rolling up. So that's an example of how to build a star schema. And I didn't actually put an OLAP engine on top of it, but these are examples of slice, dice, etc. All right, so is that kind of clear? If it is, if it's not, just send a chat message real quick, or if you need me to go over family photos again, just send it to me real quick. So the question was, is that last one a dice? And that one is a dice and a roll-up, or a dice and an aggregate. So an example would be country in Canada. This is a bit better example. I mean, it's hard to dice this one because there's only 2 years. So I could go where dim years 2005 and dim month in dim quarter, dim month in 1,2, is that right? All right, so I didn't do anything. It's hard to actually have interesting ones because this data, I mean, this data is kind of wonky. But basically a slice is when I like just say, okay, I'm gonna go and say, take this one and that one. I kind of sliced out a segment. So slices are in 1 dimension. So in this case, a slice would be mobile and laptop. So I'm slicing out those. Now I can then roll up a slice, so I can go take everything in there and then aggregate it into 2 numbers. A dice is basically a slice in 2 dimensions. So if I picked mobile and laptop, actually it's hard to do on this one, mobile and laptop, and then Q1 and Q2. So mobile, laptop, and then Q1 and Q2 is just going to be this region. And so that would be an example of a dice. And all right, so it's 1 o'clock. And we're sort of out of time. I can go on for a little bit more because the roll up, this one took me longer than I thought it would. Do people want me to wrap up, or do people want me to continue for a little bit longer? Okay, can we look back at the customer address dimension? All right, so I am completely lost. Customer address dimension. It's customer ID. It's basically just joining. So I basically made an address dimension. Address hierarchy is a better way to say it. Address hierarchy is a better way to say it. These are all the addresses that I know about, and I can get that from the stores and the customers. To get the customer address dimension, I just take this address hierarchy and join it with the customer on the customer's address IDs. If you go and take a look at customer, you can see it's got a customer ID. So I just join that in this hierarchy that I made. Now the next question is, a slice is always, yes, you can slice in any single dimension. So if I went back in here, I'm like completely lost in slice and dice land now. So I don't need that one. I don't need that one. I don't need that one. So this is my, why don't we just go back? So I actually went and did this. I actually have this one in here. Actually did this pivot table once and then apparently forgot it. I don't even know where it is. Anyway, we'll just go with this one. So again, these are my facts. So I wanted, what is, I wanted fact dim, recitation fact dim. Yeah, so I've got date and customer. So going back to my diagram, what I'm showing you here is fact, that dimension, and that dimension. If you did these 3 dimensions, that would be fine. If you want to do the staff store dimension 2, that's also fine. But I'm okay if you just have these 2 dimensions. So if you want to get full credit, just do those 2 dimensions and then do some slices, dices, etc. With respect to the slicing, yeah, you can slice in any direction. So in this case, I can only slice in 2 dimensions, date or customer address. So a slice is always in 1 dimension. A dice is sort of slicing. Now, you always do it in 3 dimensions, but it's a hypercube. So I mean, you could basically dice if your star had a lot of dimensions, you could basically dice in the hyperspace, but it starts to blow your mind when you do that. So the answer to the question, what do you need to do for this, is I would just say just do these 2 dimensions. If you want, you can add that one in. It just gets kind of annoying after some point, so I'm okay with just these 3. All right. So now I'm going to take a look at this thing. So go, there's still 52 participants, so I'm going to take that as, let's continue a bit. But before that, I want to take a 5-minute break, okay? So I'll be off for about 5 minutes and then we can resume. So let me just go back here. And I'll be back in about 5 minutes. You can all also take a 5-minute break. So I'll be back in 5 minutes. All right, there's still 43 of you here, so I'm going to take that as it's worth. So I'm back. I'm going to start. I'm going to share my screen. So if I go back and take a look at the final, in terms of cognitive, I mean, if you go back and think about some of these things, these ones, it's kind of stuff. I mean, it's kind of was a little bit annoying to do, but it's not the hardest thing to think about. Transactions are really hard. Not that there's a lot of code, but just thinking out understanding. So the reason I had you go through this example is that until you've actually done it and played with it, you can't really get a feel for it. So that's the transaction one. The star schema one, I went through that in the last lecture. It's important that you've done it at least once, because it's a good thing to be able to talk about, like, you know, if you're on an interview or something, it just kind of sounds good to talk about star schemas, and you did roll up and that kind of thing. And so you've done it at least once. You're familiar with the concept if you go take 4112 or you do some data science classes. You can see that explaining it takes time. It's just a lot of joins. The last one is kind of request a family photograph of question 8. Request a family photograph of question 8. Question 8. So the transaction one. All right, so we'll go back through family photographs. So this one is a bunch of things. So let's just do this. This one just creates an account. So I'll just pause on that one. This one does it pessimistically. You may pass the cursor in. And that's the family 8. And so I'm going to move on now. So that's star schema. And then this is the final one, graph database versus relational. The first observation is I asked you to do a lot of things here. So use the database from homework 4, use the Neo4j browser, blah, blah, blah. Write a cipher query that shows all the nodes and relationships with path length 2 or less, starting at nodes that are fans and ending in nodes that are teams. So nodes and relationships with path length 2 or less, starting at nodes that are fans and ending at nodes that are teams. So that cipher query is just going to be this. So I want to match a fan. Right? And I don't care what kind of relationship it is. And it's got to end at, what did I say? It's a team. And I'm just going to say P is equal to that. Return P. And so it's basically going to do it. So that is, starts at a fan. Technically, if I were going to be really precise about this, I would do this. It starts at a fan and it ends at a team. Oops. All right, that's redundant. So I'll be a little more precise. I would have accepted either, but you can see that of 2 or less. So fan, fan. Now part of the reason is that this one pulled that one in, but this is an example of a graph. So that's basically the cipher query. It's really pretty straightforward. And so you can take a screenshot of it if you want, but it's really straightforward. So that's one thing you need to do, and to just include a snapshot of, the graph. We're not going to go crazy trying to validate it, as long as you had a basic understanding of like how to do a multi-hop path. So that was part 1. In your schema 411, define a data model that would support fan, comment on, comment by, supports, follows, and team. Graph model of 4. This one was kind of a trap. And the thing that's a trap about this was this statement. Nodes don't have a fixed set of properties and labels. So your initial temptation would be to go and do, something like, we'll go into 4111, would be to go back into this one. And just basically go, hey, I'm going to go create a table, table's fans. I'm going to give it an ID. Okay, what were the properties? It's got a uni. It's got a last name. It's got a first name. Right. But if you did that, I would tell you, I would then go, okay, but what if I'm going to add a property? You'd have to go change the schema every time I added a property. What if I were going to add labels? So I would keep breaking it, because you can't really do this level of dynamicity in relational. Because anytime you had a label or a property, you'd have to go create a new table. And it just would be just too annoying to do. So this was kind of a trick. And I decided to back it off, because I thought most people would kind of get trapped and then just start banging their heads. This is the actual answer. Let's go find it. Is a table of things. So a thing has got an ID, a kind. That kind is either relationship or node, and then a source ID and a target ID. Those are valid. Those are not null if and only if it's a relationship. So I just kind of have an anchor, like there's a thing. So there's a thing's got an ID and I know what kind of thing it is. And then I have a table, labels. There's actually one more column in here. So labels, it's got an ID, right? What's the thing for which it's an ID? And then what's the label, which is text. And so for anything, I can ask what labels it has. And for any label, I can ask what things have that label. And then I play the same game for properties. So property's got an ID. It's the thing for which it's a property. It's the property name and the value. So this at its heart, a graph database built out from this because it's not typed. I can basically, I mean, I wouldn't even know how to do this because I can add labels. Things can have multiple labels. I can have something that I think is a fan, but then I decide it's a player. You know, what if somebody were a player and a fan? So now what do? Do you have a table for every combination? So it just doesn't work because of the dynamic typing of both the properties and the labels. So the only way to do it is this. So at the heart of every graph database is something like that, which is what are the things? They're either nodes or relationships. And if it's a relationship, what are the two things it connects? So the question is, what is the zero loopy thing here if it's a resource, right? You can't really draw some of these things in ER, but what that's saying is that the source goes back around and the target goes back around. So to be precise, there's actually two of them. See, but you know, now you start getting into diagram hell. But you can't really do it properly because what it's saying is that if this one is of the enum is of type relationship, both of those have to be non-null, and that one should be 1, and the ID has to exist. So there's really no way to draw this thing with standard ER. But what this is trying to hint at is that's not null and that's not null. But if that's a relationship, this is not null and it must reference a valid ID. To be more precise, it must reference a valid ID and the thing it's referencing must be of type node. And the same thing with target ID. So you can't really do it that easily. This is a case where the diagramming breaks down. You can do a little bit more of this in UML, but then if you remember, there's constraints. Like this has to be null if that is a node, and it has to be non-null if that's a relationship. You can't even really do that in basic UML. They tried to add this thing to UML at one point called the object constraint language. So you could express these kinds of things. So, I mean, there's an object constraint language, but UML is staggeringly complicated to begin with. And so you can start getting into this horribly complicated OCL, and then there's a similar one for resources, at which point you just come to the conclusion it's easier to write it down in text. But the answer to the question is that's kind of the answer to the question is that that's what it's trying to indicate, is that target ID may have to go and find something and source ID may have to go and find something. So that's what those things are for. But again, you can't actually properly draw this in an ER diagram. So now I'll go back to the notebook. All right. And so define a data model that would support your fan, blah, 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 blah. Everybody would have been tempted to go do types for each table, and that was the trap. If you basically go back and not going to save that. Don't save. I'm going to close others. Oops. Formula class. And then go back into here. And I show you my tables. You can see the following is I've got a table things. I haven't done relationships yet, but this is the thing ID. And what kind is it? I have a table properties. What's the ID of the property? What's the thing for which it's a property? What's the property name and the value? And then I have the same thing for labels. What's the ID of the label? What's the thing for which it's a label? What's the name of the label? And I started doing the code. So an example is, this is basically a simple test program that I have. But basically, I make a relationship graph, and I say match a node. I don't care what the labels are. The last name's Ferguson. Print the result. And you can see this is what I get back, which is this is a unique ID. These are the labels for that. These are the properties. Labels, properties, labels, properties. Right. Gives it back to you sometimes more than once because it matches more than once. Actually, probably because I ran the test. Yeah, I probably added the data twice at this point. But if I go back and change this to physician, so yeah, if I could basically go back and change it to physician, and put that here, and then go rerun it. No, gotta have both of them. So you can see it just gives me the physicians. And so I was building this object model. So there's a graph. So this is the relational implementation of a graph. It'll save a node. So basically it'll go and write the labels to the label table. It'll go write the properties to the property table. And then there's matching a node. So it goes and finds, right? Basically converts the match statement into a SQL statement and returns it. But I decided, I mean, by this point, I had just decided that we had to stop the madness. And I just wanted you to understand this basic concept that under the covers, a graph database is significantly different. So it doesn't create things like tables and stuff. It's all basically driven off of metadata. And so all you really need to do for this one is to write the Cypher query that I showed you. So that's Cypher query. Now you can imagine if I gave you a bunch of tables that were typed trying to do this thing, because I mean, like, I would not even know how to do this without writing code. And so I was trying to sort of show you that it's almost impossible to do some of these things in any meaningful way in relational, which is why there's graph databases. And then I also wanted you to basically get an understanding that this is what's going on in the nucleus. And you can see that it's actually got some interesting features, which is you can find things by properties regardless of whether it's a relationship or a node. So you can just basically, find things either way. It's got some interesting things around indexing, but there's obviously a lot of people have been working on Neo4j for a very long time. So there's a huge amount of stuff in these graph databases, but its nucleus, it's something like this, because these things are loosely typed. And so that I don't even think I asked you to do the SQL, but if you go and take a look, these are my DDL statements. So send a SQL editor the create statement. So that's my create table. It's got a label. We'll go from the beginning. So let's go add things. So create a table things. Things have an ID. They've got a kind, which is either node or relation, should be relationship. It's got a source and a target ID. These are null if it's a node. They can't be null if it's a relationship. You do that with a trigger. It's got a primary key. And then to make following relationships easy, I put indexes, so non-unique indexes, so that it's going to make it easier to do like self-joins and stuff. That's labels. It's got a label ID. It's an auto increment. Thing ID. For which thing is this a label? It's got the name of the label, primary key, label ID, and then there's a foreign key constraint. And then if you do the same thing down here for properties, that's the create statement for properties. It's basically the same. Property ID, thing ID. So what is this a property on? The name of the property and the value. It's got a property and then it's got a constraint back to thing. So that's what it looks like. And then, I'll make this code available when the semester's over, but when this semester is over, you probably are never going to want to touch a database again. But basically, you can see there's a node type and a relationship type. And then I've started fleshing out the node. So we'll go through one example of this, which is if you ask me to save a node, I'm going to make a bunch of updates. And so I'm actually going to go and start a database transaction. I'm going to insert into things. So I'm going to insert into things. So I'm going to make a thing. So this statement just basically makes a thing. And then since I'm in saving a node, I know the thing's a node. It doesn't have a source and a target, but the database generates the ID. So in the same transaction, I then do a query. Go find the largest value for a thing ID from things. That must be the one I just wrote because I'm in a transaction. So the transactions are going to prevent that. So I'm basically saying, go read the last one created. Well, since it's auto increment, the biggest number is the one I just inserted. So therefore, that's the ID. And then that's now the node ID. So I have it in memory. Right. The insert statement to add something to labels is insert into labels, the thing ID in the label. Two values for everything that's in thing.labels. Go insert the label, and then same thing for properties. This should get moved out because this is how I write code. I do it here, but I would factor this out because if you think about it, this code, there's very few differences between this and how you make a relation, just slightly different. So I do it once for node, and then I'm just going to factor it out. And then there's a match statement. So I'll make this available, but you don't have to worry about any of this. All you really need to do for the final is that diagram. I don't think I even asked you to do the DDL statements and then the cipher query. All right, so that'll be the programming ones. I did all of these for a reason, for lots of reasons, but each of them is something that's going to look good if you can talk about it, or it just tease out, all right, so, yeah, no, I crossed all that stuff out. So, I mean, you probably have not downloaded the most recent one or something, but I crossed it out. So in your schema, define it, but you don't have to do any of the other stuff. You don't have to load the data or anything. So that stuff's all been stricken out. It has been excised from reality. But if you go back and take a look, I did these for a reason. And so I kind of picked all of these for a reason. This is incredibly common. Like most applications use hierarchical data. So if you think about what an order looks like on the web, it's going to look like if you're like going and looking at your Amazon order or going and looking at your travel itinerary, they kind of look like this. They don't look like tables. So tables are really good for storing a certain way, but this is the way people think about data. And so this one just basically gave you some practice understanding the mismatch between how web applications or other applications want to think about data and what's under the covers. This one was just trying to give you a little bit more insight into what actually has to happen in Moneyball. And you're trying to decide what data you need. And you're trying to filter out data points that don't make sense. So if you think about it, I mean, if you go back into this table, so go back into Laman 2017, and you go back into fielding. So that's the fielding information. This is innings for outs. If you like go past the null ones, down here somewhere, you can see that there's guys who caught like one out. So I wouldn't classify those people as catchers. Ted Williams pitched 6 innings in 1945. That didn't make him a pitcher. And so same thing with salaries. If you don't have at least 3 seasons, you don't have meaningful salary information. So the net of it is this was basically saying, okay, I showed you the team aspect of this, but what would you do with the players to try and go get them in a format where you could start building teams? And a lot of that is like this huge amount of data here. Which ones do I need to filter out because they're not meaningful? This one, I mean, we spent some time talking about normalizing data, but it was just basically so you could understand these 2 different distinctions. So we spent a lot of time over here. We never actually went through the formality of these forms, but we talked about how you use keys and relationships and stuff to guarantee integrity for updates. But you go down a completely different path when you're doing data support, data science. And this one was just to give you a feel for what extract, transform, load. So I talked about both extract, transform, load, and map, reduce. This is contrived, but this, if you think about it, is an ETL job. So I'm extracting, transforming, loading intermediate, extracting again, transforming. So this is kind of a contrived example, but this is what goes on when you do map, reduce, or ETL. So that gave you a feel for big wide tables and also what goes on in ETL. These 3 here, like, really hammer home the difference in what you can model. So how do you think about things in SQL? How fundamentally different a graph database is, and then how fundamentally different that is from a key value store. And so when you're done, you've kind of done the same